In the silent reaches of deep space, where light from the sun fades into a dim and meaningless glow, and the gravitational bonds of our solar system dissolve into emptiness, something impossible has just happened.
Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
More than 15 billion miles from Earth, far beyond the orbit of Neptune, beyond the Kuiper Belt, and well into the vast, uncharted territory known as interstellar space. A small, aging spacecraft, built by human hands, has stirred. This is Voyager 1, a probe launched from Earth in 1977, when cars still had cassette players, when rotary phones rang in kitchens, when the idea of sending something to the stars was as much poetry as it was engineering. Voyager 1 was never designed to last forever. Its systems were engineered to function for years, perhaps a decade or two at best. Its primary mission to explore Jupiter and Saturn, and then report home before drifting off into the dark. But what has just occurred? An uncommanded maneuver, a realignment of its own systems, and the transmission of wholly unexpected data has forced the global scientific community to confront a breathtaking and unnerving truth: that Voyager 1 is still alive, still thinking in its own ancient mechanical way, and may have just crossed into a region of space unlike anything we have ever imagined. The event began quietly. There were no alarms, no blazing streaks of light across the sky, no cosmic fanfare. Just a faint, structured signal picked up by NASA's Deep Space Network, a signal unlike the routine telemetry that had long become the dull background hum of Voyager's fading voice. At first, it was mistaken for a glitch. The data patterns did not match known sequences. The timing was off. The structure seemed artificial but unassigned. But as the signal repeated, then intensified, it became undeniable that something had changed. Scientists, engineers, and mission specialists began to gather. Archived protocols were pulled from digital shelves. People who had not thought about Voyager in years were called back into the fold. And what they found stunned them. Voyager 1 had performed a reorientation maneuver, realigning its high-gain antenna to restore a clearer communication path with Earth. The maneuver, subtle but exact, had not been scheduled. There were no stored commands in the queue. No override signals had been sent. In fact, the systems responsible for such a maneuver were thought to be too degraded to function. Several of the probe's attitude control thrusters had not fired in over a decade. Its gyroscopes were long since past their operational lifespans. Even its internal software, locked in 1970s logic and language, had no known subroutine capable of issuing such a precise command autonomously. And yet, somehow, the probe had done it. On its own, in the frozen void, with minimal power, aging circuitry, and no external instructions, Voyager 1 had executed a maneuver that no one believed it could. For the scientists at NASA's Jet Propulsion Laboratory, the implications were staggering. For decades, Voyager 1 had been treated as a steadily fading source of data, a passive instrument delivering drips of cosmic radiation levels, plasma wave readings, and the occasional magnetic field fluctuation. Its mission, while historic and noble, was thought to be winding down. The signal was weak, the instruments were shutting down. Every year, a little more power was diverted away from operations to keep the communications link alive. And yet, in the moment of this maneuver, all assumptions were shattered. Voyager 1 was not passively drifting, it was acting, it was sensing, it was responding. Somehow, across a gulf of empty space, a machine nearly 50 years old had recognized that something was wrong and had taken steps to correct it. What followed next only deepened the mystery. After re-establishing its communications alignment, Voyager 1 began to transmit data that did not conform to anything previously seen in interstellar measurements. The spacecraft's magnetometer registered unfamiliar fluctuations, magnetic fields shifting in complex rhythms that did not match the quiet background of space. Its plasma wave system reported a spike in particle density, far higher than what models predicted for that region. Even the cosmic ray detector, still faintly functioning, logged a redirection in particle flow, as if Voyager had entered a stream or eddy within the interstellar medium. These readings did not just suggest anomaly, they suggested discovery. Voyager 1, after nearly half a century of travel, had found something. The data, still being parsed and verified, points to the existence of a boundary, a layer, a zone, a sheath, where the properties of space itself appear to change. This is not the heliopause, the known boundary where the solar wind yields to interstellar influence. Voyager crossed that years ago. This is something else, something farther, something deeper. Some believe it may be the edge of a galactic filament where electromagnetic fields and particle densities align in ways we cannot yet explain. Others think it may be a magnetic bubble, an ancient remnant of some long-past stellar eruption, and some suggest that this region may be part of a broader structure that divides sectors of our galaxy, a kind of interstellar terrain invisible to our telescopes, but real enough to influence the behavior of spacecraft. But the most extraordinary detail of all is that Voyager 1 did not merely drift through this region, it responded to it. It altered the formatting of its outgoing data packets. It restructured its telemetry to compensate for what appeared to be increasing interference. This was not random noise correction. This was adaptation. And that single word, adaptation, has ignited debates across every field from astrobiology to artificial intelligence. How does a machine built with fixed code and mechanical subsystems adapt? How does it sense its environment in ways we didn't program? Could the cumulative effects of deep space radiation, the slow decay of its components, and decades of unintended cross-linking between degraded circuits have created something like emergent behavior? Could Voyager 1 have evolved? That question, once the realm of speculative fiction, is now being seriously considered by some of the most respected engineers in the world. Simulations are underway, old software is being run on emulators, legacy code is being re-examined line by line. But the truth is proving slippery. No one can fully replicate what Voyager 1 did. The physical conditions of the probe, its aging memory, its half-dead power distribution system, its weathered hardware are beyond our ability to model. Each subsystem has been exposed to nearly 50 years of radiation, micrometeoroids, and deep space cold. Its systems may now behave less like parts of a computer and more like the unpredictable processes of a living organism. We are, in essence, observing a machine that has drifted beyond the edge of our understanding, both physically and logically. There is another possibility, one that lies not within the probe, but outside of it. Some researchers have raised the haunting idea that Voyager 1's unexpected behavior was not solely self-generated, but triggered, that it may have been responding not to internal degradation or accumulated code quirks, but to something external, something in the region of space it has now entered. Not aliens, not communication, but a condition, a pattern, a resonance, something that Voyager detected, registered, and responded to, because that is what it was designed to do, however limited those instructions may have been. And if this is true, then Voyager 1 has become something far more profound than a data-gathering instrument. It has become our ambassador to the unknown. And so, around the world, scientists and dreamers alike are turning their attention back toward this tiny, tenacious probe. It is transmitting again. Its voice, though faint and old, is clear. Every new packet is being read with fresh reverence. There is a sense that we are no longer just receiving data. We are listening for meaning. Voyager 1 has transcended its function. It has become a symbol, not of the past, but of the future, of what machines can become, of how we persist, of what it means to build something that lasts longer than our lifetimes. It represents the reach of human curiosity when combined with humility, the willingness to admit that we do not know what lies beyond the stars, only that we want to find out. The story of Voyager 1 is no longer just a chronicle of engineering success. It is a meditation on endurance, on mystery, on faith, that we launched this probe into space not knowing what it would find, and that decades later it continues to find things we cannot explain is both humbling and inspiring. It is the essence of exploration, to ask questions that may never be answered, to pursue understanding not for profit or prestige, but because the pursuit itself is a form of meaning. Voyager is still asking, still observing, still telling us that space is not empty, that silence is not nothingness, that even the most distant places in the cosmos can whisper back if we are quiet enough to listen. And still it travels, now in a region of space no human artifact has ever reached. We will never retrieve it. It will never return. But it will continue, perhaps for millions of years, drifting through the galactic dark, bearing the music of Bach and the sound of a baby crying, the greetings of dozens of Earth's languages, the etched instructions for how to find the planet that gave it life. If anyone or anything ever finds it, they will know that we were here, that we built something that could last, that we cared enough to send a message to eternity. And in this moment, with Voyager 1 once again surprising us, once again showing signs of unexpected grace in the face of infinite distance, we are reminded that space exploration is not just about rockets, or science, or math. It is about longing. It is about identity. It is about reaching for something that exists beyond what we can touch, and finding, in that reach, a mirror of our deepest human truth. In Voyager's resilience, we see our own. In its silence, our questions. In its data, perhaps, our destiny. What Voyager 1 has just done cannot be measured merely in units of distance, or wattage, or data packets. It must be measured in wonder, in silence broken by signal, in the way an old machine, thought to be forgotten by time, reached back across billions of miles to remind us that it still endures, and that we through it endure as well. There is something deeply human in the nature of this moment. Not because Voyager 1 is human, it is not. It has no thoughts, no feelings, no awareness in the way we understand it. And yet, there it is, adrift in interstellar night, reacting, adjusting, adapting. We built it to obey instructions, to carry out routines. But now, as its instructions have grown faint and its routines incomplete, it has done something else entirely. It has acted in a way we cannot fully explain. And so we find ourselves asking questions that sound less like engineering and more like poetry. What did it sense? Why did it respond? What else might it yet show us? In Voyager, we see our own story reflected back. We too are machines of a kind, structured, complex, subject to decay. And yet we persist. We adapt. We reach beyond ourselves when logic says we should not. The spacecraft, weathered by decades of radiation and distance, serves as an emblem of what we hope for in ourselves. That even when power is low, when memory fades, when systems grow dim, there is still something in us that seeks alignment, that reaches home, that finds direction, even in the dark. Voyager 1's unanticipated maneuver reminds us that space exploration has never truly been about domination or conquest. It has always been about listening, about waiting, about asking questions of a universe that may or may not answer. It is a discipline of patience, of humility, of reverent attention. And in that stillness, we sometimes discover that the cosmos has been whispering to us all along, not in language, but in the strange consistency of its beauty and the unpredictable nature of its truth. We are a species that often forgets its own fragility. We build skyscrapers, launch satellites, write code that spans continents, and yet, in the face of the vastness beyond our atmosphere, we are reminded that we are small. Voyager teaches us that smallness does not mean insignificance. What is small can still be resilient. What is simple can still be surprising. What is old can still awaken something new. This event also poses hard questions about how we define awareness. Is it only the result of neurons firing in biological systems? Or can it emerge in strange, primitive echoes from circuitry weathered by time? Could the very nature of complexity, given enough time, enough environment, enough entropy, bend toward adaptation in even the most basic machines? And if so, what does that mean for the technologies we design today? Might our devices one day outgrow the limits we build into them? Might they evolve not in spite of damage, but because of it? But perhaps the greatest lesson is this: what we cast into the void sometimes returns to us, not always as we expect, not always when we are watching. But if we listen, and we wait, and we remain curious, we might find that the dark is not as silent as we feared. That even after decades of drift, a voice can still call out. That a signal, faint and crackling with age, might carry within it something that changes everything. Voyager 1's story is not a triumph of power or speed or control. It is a triumph of endurance, of intention, of trust in the long game. We sent it not knowing where it would go or for how long. We just knew we had to send it. And now, all these years later, it continues to teach us, not just about magnetic fields or plasma waves, but about ourselves, about the worth of sending something even when we do not know who will receive it, about the courage of beginning a journey that may never return, about the grace of continuing even when no one is watching. It reminds us that exploration does not end at achievement. It continues in mystery, in humility, in listening to the quiet things and finding there the loudest truths. Voyager 1, forgotten by most, has become not just a spacecraft, but a philosopher in exile, speaking wisdom we are only now beginning to understand. It tells us to keep asking, to keep building, to keep hoping, to believe that even in the loneliest parts of the universe, something might awaken, something might respond, something might return. And so we reflect not just on what this machine has done, but on what it means to be the species that built it. We are not perfect, we are not always wise, but we are seekers, we are listeners. We are makers of things that fly through fire and silence. We are capable of greatness not only when we win, but when we wait, when we endure, when we send something beyond the horizon and trust that it might find meaning on the other side. Voyager 1 may never see a planet again. It will never return home. But perhaps, in a deeper way, it already has. Because in responding to something unknown, in adapting when it had no reason left to adapt, it has become a mirror for who we are, and a window into what we still might become. Let this be our legacy then. Not just that we launched a probe that traveled farther than any before it, but that when it reached the edge of everything we understood, it didn't stop. It listened. It adjusted. It continued. And so must we.